You know that feeling when you're staring at a probability problem on an exam and you just have no idea where to even start? Well, if that's you, you are in the exact right place. We're going to pull back the curtain on one of the most powerful tools in statistics, the binomial distribution. Over the next few minutes, we're going to build a simple checklist and a strategy so you can nail these problems every single time. Let's dive in.
All right, let's kick things off with a classic. Picture this. You're on the basketball court. You're a pretty decent shooter. You make about 75% of your free throws. So, if you take 20 shots, what's the probability you sink exactly 15 of them? Now, that might sound kind of tricky, right? But it's actually a perfect puzzle that we're about to solve together.
So, that basketball question? It's not just some random puzzle. It actually belongs to a special family of problems that all share the same hidden DNA. And once you learn to see that structure, they become so much easier to solve. This is what we call a binomial situation.
So, what even is a binomial situation? Well, it's basically any scenario where you're doing something a fixed number of times, each of those times is independent, and there are only two possible outcomes. Success or failure, heads or tails. You make the shot or you miss. That's literally it. At its heart, that's all a binomial distribution does. It just counts successes.
Okay, but here's the catch, and this is a big one. You can't just use this model for any old problem. The biggest mistake people make is trying to apply it when it doesn't fit. So how do you know for sure? Well, you need a simple, foolproof checklist. Think of it like your secret weapon for exam day.
And that secret weapon is a simple acronym, BIS. Seriously, burn this into your brain. It's the key that unlocks these problems and tells you with 100% certainty that you're on the right path.
All right, let's rip through what BINS actually stands for. First up, B is for binary. Each try has only two outcomes. You make the basket or you miss. I is for independent. Making one shot doesn't make you more or less likely to make the next one. N is for number. The number of trials is fixed. We know we're taking 20 shots, period. And finally, S is for success. The probability of success, that 75%, is the same for every single shot. If you can check all four boxes, boom, you've got a binomial problem.
Okay, so your problem passed the BNS test. What now? Well, now we get to the calculation, and this involves a formula that, I'll admit, can look a little scary at first glance. But I promise you, the idea behind it is actually incredibly simple. Let's crack it open. Okay, brace yourself. Here's the official formula. Yeah, I know, it looks like alphabet soup, but just ignore all that for a second. Trust me. Because the big secret is this entire thing just does two really simple things and then multiplies them together. That's all there is to it.
And this slide breaks it down perfectly. The first piece of the puzzle is just counting. How many different ways could you get the outcome you want? The second piece is about probability. What's the chance of just one of those specific ways happening? You find those two numbers, multiply them, and you're done. Number of ways times the probability of one way. That's the whole game.
All right, theory is great, but let's make this real. We'll use a classic textbook example. Imagine a factory is testing a sample of 10 light bulbs, and let's say we know there's a 2% chance that any one bulb is faulty. The question is, what's the probability that we find exactly one faulty bulb in our sample?
So first things first, let's define our terms. Our number of trials, n, is 10, because we're testing 10 bulbs. The probability of success, p, is 0.02. And this is a super important point. Success in statistics doesn't always mean something good. It's just the thing we're counting. So here, a success is finding a faulty bulb. And the number of successes we want, k, is 1.
Okay, let's tackle the first half of our formula, the number of ways part. So in our group of 10 bulbs, how many different ways could we find exactly one faulty one? I mean, it could be the first one we test, or the second, or the third. You get the idea.
And, well, the answer is pretty straightforward, right? It's 10. There are 10 possible spots for that single faulty bulb to be. And, just like that, half our work is done. See? Not so bad.
Okay, part 2. What's the probability of any one specific outcome? For instance, what are the odds that the very first bulb we test is the faulty one and the other 9 are all perfectly fine? So how do we get that? We just multiply the probabilities together. We need the probability of our one success, the faulty bulb, which is 0.02, and we multiply that by the probability of our 9 failures, the good bulbs. That's 0.98 to the power of 9. Punch that into a calculator and you get a pretty tiny number,
about 0.01667.
And now for the final step. We just put our two puzzle pieces together. We have 10 possible ways for this to happen, and each one of those ways has that same tiny probability of 0.01667. So we just multiply them.
And boom, there's our answer. 10 times 0.01667 gives us a final probability of about 0.167, or 16.7%. See? By breaking down that monster formula into two simple questions, how many ways and what's the chance of one way, we made it totally doable.
All right, doing all that by hand is awesome for really getting it, but let's be real. On an exam, you need speed. Plus, questions rarely just ask for exactly a certain number. They love to use phrases like at most, at least, or fewer than. And to handle those, you've got to know your way around your calculator.
Okay, pay attention here because this slide highlights the #1 trap on statistics exams. Just misinterpreting the words. You have to be a translator, turning English phrases into math symbols. At most, 5 means 5 or less. At least 5 means 5 or more. Getting this translation right is, no joke, half the battle. Luckily, your calculator has two magic buttons for this. You've got Binomial PDF and Binomial CDF. The way to remember it is simple. Use PDF when you're looking for an exact number, a single point. Use CDF when you need a cumulative total, like at most 5 successes. Knowing which one to press is a total game changer.
Okay, we're almost there. Let's finish up with some quick pro tips and the most common traps to watch out for. This is the stuff that separates a B from an A, so listen up.
First up, when should you absolutely not use the binomial model? Simple. If any of your BINS conditions aren't met. If there are 3 possible outcomes, it's not binary. If you're drawing cards without putting them back, the trials aren't independent. If the probability changes from one try to the next, it fails the S condition. Knowing when the tool doesn't work is just as important as knowing how to use it. And finally, here are the top 3 mistakes I see people make over and over again. Number 1, just forgetting to run through the BINS checklist in their head. Number 2, mixing up PDF and CDF on the calculator. Remember, point versus cumulative. And number 3, the absolute worst, the off by 1 error, especially with tricky at least questions. Always, always, always double check your numbers on those.
And that's a wrap on the binomial distribution. It's not just some scary formula, right? It's a whole toolkit. You've got the BINS checklist to know when to use it, you've got the simple logic of how it works, and you've got the calculator strategy to get the answer fast. So the next time one of these success or failure problems pops up on an exam, you're going to be ready.